Q501. Q504. So Q504. Where do we start? Resistors. Hey, welcome in. We're just going to be doing finishing off this PC Engine GT. To be honest, we've not been finishing off this PC Engine for a while, and I think I've got all the parts I need now. I think so. We're going to try and wrap this up. Yeah, mic should be working. It might have just toggled on and off. I just noticed the it wasn't passing through the right parts of the stream, but it should be. I presume it's back up and running for you now. I was just messing with it for a minute then. I'm from Stoke in the UK. Right, so that's 500k. That shouldn't really be a resistance. Let's try this side. I'm just trying to identify these last couple of transistors as well before we put them on. 42k. Yeah, so I'm pretty sure I know what this one is. Well, I do. So this is a epitaxial transistor. I think I suggested it might be that on a few streams ago. I'm pretty sure it is. It might not be this exact one, but it won't matter too much on specs. Jump back onto this port. Well, we'll need that in a second. I'll leave that where it is. Bring the PC up over. So I think it's one of these, an epitaxial transistor. Not that common, but basically you've got two bases to two. I think these are NPN transistors. I can test that after. So two NPN transistors with two separate bases, but the bases are already pulled high and also available on pin 4. So you can control both the center tap point and the bases. So typically for low voltage drop bi-directional switches, I'd say they'd use these for. I'd use this setup in a 2 MOSFET configuration for a 0 voltage drop setup. So without getting too technical, I'm pretty sure that's, well, 99% sure that's what this transistor is. So Q504, that's what I'm going to go with, and just write it in the bill of materials, which is over here. Oh, I've moved it. Where have I moved it to? Open. Browse. PC engine GT resources. There we go. Moved it out into Git. So we have now on screen. Actually, I've never checked if this works yet with the scope and the screen. Yes, it does. So Q504. I'm going to go with the part number I've got written down, which is an XN1211. So it's going to be an XN1211. Well, that's really going to be, well, yeah, in here, to be honest. So it's a epitaxial NPN dual transistor. That'll be enough for now. And then we have, what else have we got left on this board? There's not much left on it. I think there's like 3 transistors, and hopefully the other ones are similar. Then we got Q902. Is that 9L as well? Oh, 99L. So it's going to be suspected this will still be a similar spec, maybe a different layout. And this 5B or 5R, can't really tell. Oh, turning one of the lights off. Bit hard to tell. Let's try cleaning that up. Streaming this evening, all depends. The mornings, sometimes I forgot the mornings on Thursdays and Mondays will be quite hard because I also generate orders for packers. So I've just done that before I come on stream. That's why I'm a bit late. Evenings all depend on how the day goes and what I'm doing and where I'm at and how I feel, kind of thing, because I've already done quite a long day by the evening. But I do usually like to stream at the end of the day, usually about 3 or 4 p.m. So I'd say, what day are we on Thursday? I'd say probably, yeah, I'd probably come on for an hour or so. Maybe between 4 and 6 is probably roughly when I'd say I'm going to jump on if I am. Yeah, I am from Stoke. Welcome in from Wisconsin. Used to have a business over there and I travelled a lot. Used to love the weather. Just nice, cold, crisp air, but not too cold. Thanks for the order as well, Jack. So 5R, let me just see if we've already got any transistors written down with 5R. Because I know we had, I'm sure we had 5s somewhere. It was a while ago. Scrolling up. Oh no, it was diodes, wasn't it, that? Can't even find any notes with the writing on. I know I definitely wrote down in the bomb the numbers that would proceed. Well, I don't know why I'm doing that. They're literally on the board, man. So just look at the board. I'm scrolling through trying to find them. They're just on this board. So we had 5H. I bet we haven't got 5R, have we? And the 5H is on a transistor as well. So I'm just going to guess that the 5 is a designator for the type, which would mean that Q501, if we look at what that is, let me actually sort this spreadsheet now, but well, I'll sort it in a moment when it's filled. Q501 is a dual NPN transistor. So I'm going to make the assumption that this one is a dual NPN transistor. So we'll take that off and put it through the component tester. Oh no, it can't because it's 5-pin. Yeah. I wonder if that's similar. I wonder if all these are epitaxial transistors. So if they are, then a typical sign for quick reading is if we go over the outer 2 pins, we get a high resistance. Now we're getting nothing, so it's not that. Fresh outer look, so it's not going to be there. Let's put it in diode mode. See if we can spot any diodes on any kind of layout. The Wirral Stoke-on-Trent in Milton. I don't know whether. I think this should be making sound when we do a chat message. Let me just pop a chat message on a second. I think oh yeah, it does. Just want to make sure it pings so I don't miss messages. having any luck with identifying this one with basic diode mode. That's interesting. Oh, there we go, found something. So, oh, it's gone again. So that's going to have charged a gate up. Hang on, these testers are not good. They're dirty. What drink do I have? It's a punishment drink. I brought a load of them thinking they were going to be nice. So I went ahead and just brought like, I don't know, 12 or 24 of them. They look ace, but then I didn't notice they were sparkling water. Some sparkling water's okay. These were vile, but because I brought so many of them, I'm forcing myself to drink them. But the irony is now I've drank about 10 or 12 of them. I'm starting to like them, even though it was probably one of the most disgusting drinks when I first had it. I must be used to the sparkling water taste now, so just a bit better for you, really. Getting a bit more water in. Yeah, so we had one beep, but my testers haven't been working on the tips. They were quite gunked up, so I'm going to have to try that again. In fact, let's just hot air this and give it a good clean first, so it's nice and clean of flux. Otherwise, it's going to make the testing a little bit harder. Yeah, so all that flux is going to be doing us no good. It's going to get in the way of the measurements. Give it a second to cool. And then that should now be a lot cleaner. So, now let's see. We did have a beep, I'm sure. There we go. So, there to there. So this is our cathode, this is an anode. So we have a diode in here. The fact it's Q, it's going to be a transistor. So we're going to have either an NPN or a PNP. We don't know which yet. So there's one there. So that's one. Let's try this pin, the other side. I wonder if it's just, this could be a Darlington transistor maybe. So there's an NPN there. And there's nothing there. So I'm guessing this middle pin, yeah, is going to have a cathode there. So we've got a cathode, two cathodes, three cathodes, two diodes. Right, so let me try and draw this so I can try and figure out what we're looking at. So we have, doesn't look very clear. I think it's just a reflective board. Let's see if we can figure this out. Well, we can figure it out, but I'm just trying to think what it might be. Without drawing it down, it might make it obvious. So we've got the 5 pins like this. We know we've got a cathode here and here. And are they shared or distinctive? So 2 separate cathodes. So I think we might even have a triple diode packet. I don't think I've seen a triple diode package though. So we've got this pin, say coming off here. It will have the, which way around is this going to be? It's got the cathode there. This has also got a cathode, so we've got that there. They both share an anode though, so the anodes both go to here. So that's the package there, the little black package. And then obviously if I draw around where the pins are, so it's a little bit obvious where the pins, I don't know, this will make it less obvious or more. We'll kind of try and highlight where the pins are versus the lines. Yeah, maybe a bit more clear there. So you got a diode here, and this might be a transistor in a package, but measurement wise we're getting a diode. This was also a cathode there with an anode to here. So that's what I'm seeing on the measurements, just pure diode readings. It wouldn't be a Q though, because a Q it'd be a D if it was diodes. So it's going to be a transistor package. And then obviously transistors have diodes on the body. So when you see, say a transistor package, which would be, say a classic circle, you go down into your base and then you come out here. So you're either going to have an arrow pointing in and coming out. And this is your diode here. you can have body diodes as well. So on MOSFETs, you typically have a similar thing, 3 little lines. I can't remember the shape exactly, but you'll have, say, an arrow down, going off, this going out. But you'll have like a diode, a body diode going over here. And it would be whichever way. I might draw this the wrong way. I'm not really thinking about direction at the minute, but you'd have a diode going over the package. So you'd have like a, gee, I'm going between NPNs and MOSFETs here now. You'd have a gate on the MOSFET, a source and a drain. So the source would, say, be down here, drain up here. Again, ignore the directions. These I might have drawn it backwards. But over, say, the drain and source, which is the same as the collector and emitter on an NPN, you'll have a body diode. So you could be measuring this body diode as here. So I think the best thing to do is, I don't know whether we look for transistor packages that are 5-pin in this and just give us some ideas, or put it in the tester, because nothing's standing out to me obvious here with just these diodes in these positions, what orientation or package this might be. And the other one was quite hard to figure out because it was a epitaxial, which is not that common. So I think it's going to be a DigiKey search, I think, for the minute. Let's see if we can find anything that maybe helps us. No way. Earthquake in Australia. I know they've been having some really bad weather in cruise ships. I don't know whereabouts. I haven't paid that much attention to the news, but I know there's been a lot of activity in the oceans on cruise ships recently, like really bad. Right, DigiKey. There's 2 things we can do. We can either look at like PC Engine schematics for similar parts of the system, or we can look on DigiKey to try and find it. But this Q503 is very close to the power regulation circuit, so you'd think it was something to do with the power regulation circuit, which won't exist on the PC Engine. So I don't think we're going to find anything that useful looking at the other ones. But let me just search around them in. Just going to do some blind hunting. If I can't find it, I think we'll just transfer these chips over for now, and I'll figure these out after, because it's going to take a bit of research and probing and all sorts to figure these out, and I want to try and get this build done. This is just to identify the chips so we can buy them again. Basically, it's not that crucial that I do it right now. It'd just be a shame because we've identified everything except 3 transistors on this entire board. So I kind of do want to finish off identifying them, but let's see how far I can get in, say, 5 minutes. And then if I can't figure it out, we'll move on, and I think I'll just transplant these over then, and we'll, come back to find the identity of those few chips that we've got on there. So, yeah, there's going to be nothing on the PC Engine schematic. I think it's definitely the power regulation side. 501 was a 6-pin dual. We see we've got the only 5-pin transistors we've got is the epitaxial one we've just identified, so it's not going to be that. Yeah, okay, so I think we're now down to a DigiKey search. Semiconductors. In fact, I can show you how to do this, because you might be interested, save you just looking at me talking. Let me drag this over. And let me pull up the screen. There we go. So what I'm doing is I've just gone to DigiKey, search transistor, and now there's a load of transistors here. So we've got arrays, so you've got multiple transistors that are pre-biased. It might be that. It won't be single diodes or single transistors because they're 3-pin. We don't care about FET arrays. It's very unlikely. All these are unlikely. JFETs are unlikely. Their sockets, singles, and FETs aren't likely. So the only thing we really have is, it's not going to be a single pre-bias because we've measured 3 diodes. So it has to be at least 2 transistors of some form. So we're down to BJT arrays, which are probably just going to be straight arrays, or which it might be. or pre-biased arrays. Now, I'm not sure where the epitaxial fit in there, which ones they fit into in that category, because they're clearly part of that category, but they probably don't really make them much anymore in them packages, maybe. So now we're in, say we'll start with this one, the pre-biased bipolar transistor packages, basically. And we want to sort by the package. So this package is likely, and you just get used to this through experience, the 5-pin, that looks like a SOT2 package. So if you want to identify the package, what we can do is, if we go over here, zooming in, and this is the one we're trying to identify. So I'm going to say, take this package here, get my vernier or calipers, zero them out, and then maybe zoom out a bit. Now you know what I'm going to do, so you can actually see the screen. I want to measure. First, you can measure like the body package, which is 3mm, 2.9, and then the pitch over the pins. So if we go to, probably go to the microscope view for this, maybe, just so you can see nice and clear, considering we've got it. So over here, what I'm going to do is, as accurately as I can, I'm going to get my vernier in here. I'm trying to look at the inner blade of the verniers being on the center line of the metal pad. So see the left tip? I put the left tip, say, on the left edge of the pad. That's the center, and that's the right edge. So if you're looking at this tip here. So I'm trying to get that central over that bit there. So that's now center of that pin. And then I'm trying to move this one so the width opens, and basically both tips fall central. And that now means we've got 2 pins in there, 2 gaps, so 1, 2. So that's this means this needs to be divided by 2, and you can see we're exactly, we zoom out a little bit, we're exactly 2 mil. So that's going to be a 1mm pitch. There's a 1mm gap between the pins. So you have now a package that's got 5-pin. It's clearly a SOT package. It's 5 pins, and we've got a pitch of 1mm. So from there, I will pull up Tinterweb, and I will basically type in, I'm going to guess, firstly, a SOT23-5 package footprint. I'm on the wrong screen, drag that over. So all I've typed in is, firstly, the package I suspect it is, which is a SOT23-5. We can now look at the footprint. So this is the pads, the solder pads, basically. You can get them in multiple places. And you can scroll down. This is a different one. SOT23-5. So visually, obviously, you can have many that look very similar. Alternate names of the packages, because you can have various names. And then this is what we're interested in. So now you can see there's a width here of 0.95. So almost 1mm. So that's our vernier measurement, very much likely, just slightly out. So that adds up. So then let's measure the package, 2.8 mil. Now you remembered we measured 2.9. So that's the width of the actual black body. So the final confirmation is just the width or the length, whichever one classed as. The other dimension is 1.5 millimeter. So to kind of affirm, if you will, what we think, we want to check if the black body package is somewhere within 1.5 millimeter, and then we're good to say this will be a there you go, 1.56. So zoomed out a bit, you can see we got 1.56. So we've identified that package as a SOT23-5. So now we know that, we can narrow our search in DigiKey. So if I now pull that back up, discounts on the site, yeah, if you sub to YouTube or Twitch, then we are going to be doing discounts. We're going to be hosting a subscriber only Discord, basically, where you can get discount codes. Yeah, the sounds of the notifications still aren't coming through. They seem to be intermittent. Let me just see. Or maybe I've turned them off. Let me turn these on. We might get a load of spam audio now doing this, but let's just see, because I had all the audio turned off. So if anybody wants to like the stream, do all the bits and events that make pop-ups, let's see if they make noises. I think it's like if you have so many likes, or you follow the channel or stuff like that. So next time that happens, let's just see if that pops up with the little noise, just so I don't miss events, and then I might have to turn it off if there's too many. I can't remember what ones, but I'm sure them pop-ups should have made noise. Yeah, so now we have the package. We can filter the search results now by that package. So if we look at in the supplier device package, we want SOT23-5, and you can see it's not got the SOT23-5 in there, but there was the SC74A. So you can see you got SC74, so maybe they've used that synonym instead. Yeah, so we're getting a pop-up, but where's the thing? Not sure where we just had the notification there, but nothing show up. Oh yeah, so that's the message. So some chat messages don't actually show up on stream if you're not a sub. So that was a chat message noise coming through. So the chat message noise works. It's mainly the little alert things that pop up. So there's none in the SC74. So let me just pull up those SOT 23-5 package alternative names. I can't remember what they are. There's the SC74, the SOT 753 is another name for it. So let's try SOT 7. Nope, can't see that. I wonder if we've got one in here. There we go, SC74A. Let's clear the other one, so use package case instead of that. And then the SOT, what was the other one? SOT 753, which is linked there. So I'm pretty sure that's going to be the right filter for the package size. So we've got 26 results for that. And now let's see what we're looking at and see if anything gives us a hint of what we might have here. So let's just take the first one. Doesn't really matter, they're the right package. So we really want to just look at what we have there versus, I guess, what we've drawn here. So if we put this up over, this is what we're going to try and find something similar to. And here's the package. So this is what we're ultimately looking at. So this is our package. If we have now, you can see a transistor on, you'll have a diode that reads from pin 1 over to pin 2 potentially on that. But on here, this is almost an epitaxial setup. But obviously, all it's doing is pre-biasing the base where the resistor pulling up. So we'd have resistance between pin 1 and 2 if this was the case. We also shouldn't have a diode reading between pin 5 and 1 because that's the base and the other pin, so it's not going to be that. Pin 2. Oh, hang on. No, we might. Ignore me. I'm looking at the pins wrong. No, that's backwards. So this diode would match because you've got the diode running, if you drew it inside, that's running from the base through. So that isn't the one, I don't think. So no, pretty sure it's not going to be the one. So that rules out, and to be honest, if that's all of them, if they're all pre-biased NPNs, PNPs, let's just look at the PNP one, see if this makes more sense. And if I draw, let me just draw inside if we're looking at this, so it's a bit more visual as well. We effectively also have, not an extra diode, but just so I can visualize it easier, we'd have a diode doing that, and this one would be a diode doing that. Just so when we're looking at packages and you can see the little transistor inside, you can get an idea. So that would be running from pin 1 the opposite way. So let's just redouble check this. Now I've drawn it slightly different. That's one way, that's the other way. So that's the diode we say would fit with the base of the first transistor going to the emitter. But the one going up won't. And the other side has ultimately this going in. Op-amp, I don't think it'll be an op-amp, by the way, because it's got a Q on. An op-amp would normally have a U designator. It's not saying it won't be. I just can't imagine it being an op-amp, and it's part of the voltage regulator circuit. So this, well, saying that, you know, maybe, because it's connected to the Zener diode. Let me look at what the Atari Lynx does. Because the Atari Lynx has got a Zener diode in the circuit, and I'm wondering whether that's going to give me any hints at what we might be looking at. Schematics, Atari Lynx, and I've done a whole ton of reverse engineering on the Lynx power circuit, so I've got quite a bit of knowledge on it if I can remember anything about it. So pull this up. So we have on this circuit, we've got a Zener diode here, basically. But this just goes through, again, a basic transistor. So that will be a PNP transistor there. Yeah, and this isn't an op-amp. This is a hex inverter, basically. Yeah, so that doesn't give me any clues. But I don't think it's going to be an array, unless I'm staring at it and misinterpreting where the diodes are going. We don't have, from pin 1 to 2 would go through here, but then you'd expect pin 3 to 2 to have a diode reading. To be honest, if it's any pre-biased diode in this package, that's what we'd expect. So let me just check to be sure. We don't have a diode reading between the outer 2 pins, so meters are working. No, so there's no connection between there, so it's not going to be, I can't imagine it being any of these pre-biased things. Yeah, so the follows aren't popping up, like the little notification sounds aren't popping up on a few things. Why would that be? We've got that sound connected there. Doesn't matter too much, but I'm sure we normally get noises for the follows and things. The chat noises are working. Well, actually, they're not all the time. Otherwise, I'm kind of missing the chats. I'm not sure what's going on with me audio. Desktop audio, maybe. I don't want to enable desktop audio because that should come through the speakers anyway. Okay, right. I might just be a bit late on spotting audio, basically chat and notifications, because I think the stream isn't popping sounds up. So I'm going to ignore that. Otherwise, I'll be messing with the stream for ages. So if it's not going to be these just pre-biased packages, I can do. Well, let's have a look at the transistor types. You can really only have 1 NPN, 1 PNP, maybe. That's the only other configuration. We've checked NPNs and PNPs, so let's try the only other one. There's literally one package for this. If this doesn't match, it's not going to be that. Oh, this is an interesting layout. And it's not give us a pin. I hate when they do this. So they've drawn it like this, but then not give us a very clear indicator of where the hell the pins are. So you have to like look at this, go pin 1, 2, 3, 4, 5, and then you've got to look down here and remap. Oh, they've actually laid it out fairly similar, to be honest. So this is like the shape of the package, but that package is upside down for us. So if we rotate this around, and now we're looking at the packages here, you can see basically where the legs come out. That's what we're looking at. So that would mean we'd have pin, I want to say pin 3 to pin, where is that going to go? Pin 3 to pin 5 or pin 3 to pin 4. So maybe that one. Pin 2 though would have resistance between pin 2 and 1. So again, if it was this kind of package, we would have resistance over, I'm looking for this R1 and R2 resistor. If it was this package, pin 2 and 3 would have resistance, and they wouldn't be that high. They'd be in the kilo ohms. So that would be the board this way around, and we'd have resistance from this pin to this pin. And we actually do. We've got 500k. Now, that might be about right. If so, then we'd have resistance from pin 3 to pin 5 as well. We'd have resistors coming down through pin 3, through here, down to there. So pin 3 and 5 would have resistance as well. And we don't. That's got 7 mil. So it's not going to be that either. So we are pretty much saying it's not going to be a transistor array that's pre-biased. So now we're just on to transistor arrays, which again we need to filter by package. So we did package on here, and we did, I think it was SOT 7.3 we did, yeah, SOT 7.4a. We don't really care if they're in stock or not. We just want to see what options we're dealing with, see if anything else rings a bell. So there's various kinds. There's 1 NPN, 1 PNP, two with match pairs, complementary Darlington. See, I suspect a Darlington would maybe make sense here. I just keep going back to the fact that it's to regulate voltage. So would it be a current? It's not going to be a current mirror. No, it's not going to be that. Let's just look at some of the data sheets. So let's start with a 2 NPN matched pair common emitter. Pin 2 and 3. All right, so let's look at this again. That's the orientation most data sheets are in. There'll be a diode flowing this way, which there isn't, because that's going to be a base, so it's not going to be that one straight away. So it's not a 2 NPN dual match pair. Let's try a common emitter. Now, the thing is, we've got one common, and the others aren't common. This almost seems isolated. This is going to be strange to figure out. This one is. I think it's going to be one of them packages like the epitaxial one, where it's just not something that's common anymore. We may struggle to. I'll figure it out, but I think this one might well take a while. Nothing at all is standing out as an obvious layout for this. I'm sure when we find it, it's going to be very obvious, and we'll just be like, "Oh, that." You know, it's kind of was obvious, wouldn't you see? But no configuration is lending itself to this layout at the minute. And normally, this is the common pin. We've got a common anode here, which is strange. I mean, you could have the most obvious thing, which is just literally 3 diodes in a package, and you've just done a Q designator. There could be nothing else in this package. It could literally be 3 diodes. But then you don't even get triple diode packages anymore, so you wouldn't even find this or know this. I'd maybe have to put this in a component tester and just test every combination of 3 pins to see if it picks up that there's current flowing through one. And, you know, if it notifies and figures out there's a transistor, that's probably what it was. So for now, I'm just going to leave this for now. I'll figure it out. I don't think you guys are that bothered if you see it being discovered. You know, I'll kind of tell you when I find it, but that's the process I'm going to go through. I'll keep looking for packages that look similar. I'll probably take this chip off and put it through the component tester in every orientation. And basically, I'll figure it out that way. I'll find out there's going to be transistors in there. It's just a process of elimination and time. So for now, what I'm going to do is make sure I've got notes on the Excel sheet of all these parts we haven't identified yet, and then I'll come back to them. There's only like 3 or 4. Hey, thanks for the 6 emoji. Right, so we have Q504 we've identified. Q902 is blank in there, and Q503 is blank. So the Excel sheet's also fine. That's got everything written down that we know of, and we have basically got 3 chips we don't know of yet. So let's get to some work. We'll go to the overhead. We'll pull focus. So what we want to do is transfer the remaining parts over. So we'll transfer this little Q504 over. We are making a PC Engine GT. Well, we've already made for the most part. So we have the customer's PC Engine GT here that we've done a whole lot of work on. This is like 14 hours I bet now on it. Transferring everything over from the customer's old damaged board over to the new re-PCB. But we spent all the time, as what you've just been watching, trying to identify every component on the board. So that's what's taken us so long. I've spent like 12 hours identifying every component, and the only ones we haven't identified now are 3 transistors. Other than that, we know every single component on this board, which means we can get a factory to pre-assemble these white boards for us now. 99% assembled, basically. So when we come to do this work afterwards, to transplant the key chips over, like the Hue chips, this job will be much quicker. So let's get these transistors over, and we can actually try and bring this up and see if this PC Engine works, because it didn't even work for the customer. If you remember from the start, we had a completely non-working board. So he had no audio, no power, no video. It was basically dead. So we'll see how far just transferring the chips over to our board has got us to a working PC Engine GT. So it may work straight off the bat. It may not, but we will see. Now that transistor's on, we can also, we can hot air this connector on. So let me find that connector actually. There. So the only other part left from the customers is this connector. And I've got a spare box back. So the way I do these is to hot air from underneath, but you can also iron them. So considering I showed you how to hot air these ones on the last time, let's have a go at soldering this on with an iron. Now we've got the microscope. That's good, because I really need depth perception when I'm doing this one. So I'm gonna go over to the scope, pull the scope up, and look at that for a seamless transition. We'll go on with the extra lights. Oh, nice. I can actually see what I'm doing now. So you guys can now see close enough. Let me see if that's perfectly in focus. Yeah, I think there's like good focus. And now I can work. This is the first time you guys will have seen me actually soldering with depth perception. This is something you don't see me doing, because I have to solder from a top-down camera with massive delay. We still manage. I'm going to put this fan on now as well. I keep saying I really need to get this fume extraction stuff sorted, otherwise I'll have really bad throat. So I'm just going to I'm going to clean the tip of the iron first. Then I'm going to put flux on. And we'll probably need more of that. But I'm going to pre-tin just one pad, so try your best to just tin one pad, like so. And now I'm going to get the connector. It's a little bit awkward. I could do with some different bent tweezers, because I kind of want to, I might have to turn this around this way. Yeah, just because I can't hold the connector in the tweezers. And what I'm going to do then is come down with the tweezers, warm up this pad and slide the connector in, but you don't want to slide it in and melt it on. Oh no, my little fan's run out already. That was a good fan. Let me plug him into charge. You don't want to melt the plastic, so you need to Basically, watch where you're soldering and pre-plan. So I don't want to melt this connector on this side. So you can see we've got a connector over here I don't want to melt. And we don't want to touch the iron with this one. So just be very aware of where you're positioning your iron. When this comes in, it's going to almost touch that tip. So I almost want to be down here. And then warm that pad up, place the connector on. And it doesn't have to be accurate. You can see it's all floating in midair. But warm it back up. And the first pad, you're not that worried about the quality of the solder joint. You're trying to go for position. So that looks like it's in position now. Maybe slightly up. There we go. And the irony is the silk screen behind, the black line looks out of alignment, but the actual chip, the connector is in the right position. Let me see if I can just prod this up a bit as well. It's slightly slanted because there's things on the board, so we need something just the right height. There we go. So that's the right height now. Bring it back into focus. So that's the first part of it. And now all we need to do is, if you're doing an iron, I'll go from the other side, tack this pin in, and then I'll probably just drag solder down. So we'll go and tack one more in down here. And you can see there now what it wants to do is just bridge. That's perfectly fine. All we do is plenty of flux. Go down slowly with your iron, a lot slower than you think. And the heat will transfer through. And you'll normally just drag that off. And you want to get plenty of solder, so you can see these end two here haven't quite got solder onto the PCB. All the other seem to have plenty. There we go, they've all got plenty of solder on now. So let me clear that up so you can see. Hey, morning. Yeah, not doing too bad. We're just going to hopefully fix this PC engine up. Looks slightly out of focus. Is it? Or is that just the... Yeah, we were slightly out of focus as well. So what I was looking for first is to get these... See how this pad here... Right, zoom in for you. See how this third pad doesn't look quite the same as the rest? These have got nice, shiny solder joints. And this one still looks a bit dull. So... ignore the joints, like people try to focus on, oh, I've got a bridge. Ignore the bridges until you get the solder flowing onto the pins nicely first. So we're going to go back in with flux, try and steal some solder from this connector and get it to bridge over. If it doesn't want to bridge over, just add a bit more. But the goal is, you can see how it's gone shiny now, but you can add a tiny bit more and get the pads nice and round. And it's mainly getting the heat down to the pads. And then once you've got plenty of solder on, now the job is to remove these bridges. So on these connectors, sometimes the easiest way to get the bridges off these, because they don't naturally want to flow off the connector, is just use a tiny bit of desolder braid. You don't normally do this because it takes too much off, but I know these connectors and I know how they flow. You want to just take off the excess with desolder braid like this. But you want to be careful you don't take off too much. And then you still see you've got a little join here at the top in all three. That's no problem, because now if you clean your iron and you don't have much solder on your iron, fresh flux and go back on it with heat, these should naturally flow back off now if you get them warm enough. And all of them did until that last one decided to go back on. Clean the iron, go back on. And I think that's now got them all. And the important part here is you need to make sure you put plenty of solder on, because that's why people avoid, they don't want to put solder on because you get bridges. But you really need to put the solder on to get these nice formed connections. So see how we've got nice balls now, like nice flown pins. If you don't put plenty of solder on, you won't get that you won't get them pins to flow nice, and you'll end up with the joints will still work, but they wouldn't be as nice, basically. So flood it with solder first, get your connections all good. I'm just warming the board up so I can remove that flux, because it's doesn't want to come off. And turn that fan off now as well. But you see how much as well, how much more work that was to do than hot airing. So you can see that's why I prefer hot air, because the other ones we just pretend all the pads hot aired and they're all perfect. Whereas the hand soldering like that, you can see, takes more time and takes a lot more work to get anything that you'd say is, you know, as good as the hot air one. Plus the flux does not want to come out of the middle of these. Let's give it all a helping hand. And again, won't be too much of an issue because I will probably thoroughly clean this board after. But we have kept the board pretty spotless, so I really want to get as much of that flux out as I can. But yeah, if you can hot air, like I do, I'd highly recommend the hot air over other things. It's just with plastic as well, you also have to be careful that you don't melt things. So there's a balancing act between ease of solder and also the risk of doing damage to a board. You have to balance the techniques you're using, and it changes per board as well. Everything's different per board. So now that's on, we have, did we put this connector on? Yes, we did. There's literally just Q902 and Q503. We haven't identified them, but I'm just going to solder them over. So obviously hot air again now, we'll go back to. I'll tell you what, when you're looking under the microscope there with all the extra lights on, it feels dark once you stop using the microscope. So we'll get some flux on here. Flux on here. See, so again, we got like I don't know, they got delayed noises or something there, but the sound on this setup at the minute's going right funky. So we just had 2 pings and nothing's there, and yet we've not had any chats come in, not had anything on stream. I seem to have missed. The sound is definitely a little bit funky on this one, unless somebody sent messages and they've the bots deleted them or something. All right, so let's transfer these last 2 chips over. So we want 902 going over first. Let me just toggle in and out of the chat actually as well, in case it is. Yeah, everything's on and clicked in. Yes, yeah, just basically, like I say, bear with me with the chat and stuff. I might miss it because the sound's just completely all over the show today for some reason. So, you know, that one's worked, so thanks for the follow. So I think like one of the pings is working. And then a chat come through at the same time then. But yeah, these are definitely all over the show, the audio. Looks complicated. Yeah, it's a little bit complicated. And do we let the board cool, or let's just move over to the other transistor and then we'll clean the board in one step. So that one is hot airing off there. Moving over and plonking on there. And I suppose if we can't, for whatever reason, if we can't actually identify them few transistors that are left, they're on the power regulation circuit, so we could replace this with our own power regulation circuit if we wanted to offer like a pre-populated board with as many components. We could just literally replace this circuit design with our own switching 5-volt circuit. It wouldn't be too complicated. So I think that is actually now the customer's board finally fully depopulated, if you will. So the customer can get this back. The only thing, might give that a little bit of a clean. Probably get a cloth on that as well. The only thing I did on the very beginning of this was the contrast wheel, I think it was, got melted too close to a connector. I did manage to source some on AliExpress, luckily, so we're going to also fit that back in. The only thing is, I don't know, it's a plus or a minus, but it's got numbers on, so indicating the volume, so it's maybe classed as a cool upgrade or something that you don't want, but you can probably wipe off the silk screen with IPA if you want. So if we just move that back out the way for the customer, we're now dealing with a fully populated, move that off, get a nice little view. We've got now a fully populated PC Engine GT, so this is a fully done re-PCB. The only thing we've got to do is put this wheel on here. I've put the connector on another stream, so instead of this being a ribbon, like, you know, this prefix ribbon that melts, basically, we've changed it for a connector. So we've got to do the same on this side as well, with another connector, and then I've sourced a ribbon, so we can now go on here, and hopefully if this is right, yes it is, we've got a little ribbon connector, so we can insert a ribbon in here now, close it down, and we have a detachable front PCB. So that's like a cool upgrade. So I'll need to put the other connector on and the volume wheel on now. So we have, these are what I've found on AliExpress, the only place in the world I can find any, even my own factory that I use all the time for parts and production in Shenzhen can't even find these, but some random small factory on AliExpress has them. So these are the ones I've found. Probably hoard quite a few because we might need hundreds, but this is the exact, or looks very much like the pinout and the exact value, and we've even got dials on for the volume level. So this is going to replace the one here, and hopefully, I genuinely haven't tried this yet. Yes, fits in perfect. That slides in, and the customer's now got a volume dial. It's going to tell him how loud the audio is. Like I say, I don't know whether that's going to be a good thing for him or whether he won't like it, but that's in. So I'll hold that down, get some solder and tack this in. Thanks for all the follows as well. As I mentioned, they're not pinging up with audio at the minute. The audio is just a complete random mess. So you'll have to bear with us on the random audio not working, then working. And I will tack these remaining pads in. And we've got mounts at the front there, these two mounts. And the irony is, if this is, I don't think it's the volume wheel, I think it's the contrast wheel, sorry. So he's got a contrast wheel, but that would literally tell you where you need to set the contrast, but he's having an upgrade. It's having an LCD upgrade, so this isn't even going to get used. So now it's purely a visual wheel. Now he can set the number to what he feels like. Hey, morning, welcome back in. We are finishing off. Hopefully we're going to get this PC Engine GT brought up and alive today, if we can. We've got all the parts I'm pretty sure I need now. We haven't identified the couple of transistors we had left. We've just put them on for now. We tried to identify them. We figured one out, but we couldn't figure out a couple. So there's a few things on here, a few transistors I'm going to have to go back to on mine to try and identify. But that doesn't stop us working on the customer's board. So this is all on now. We just need to put this connector on the game slot so we can actually load a game. So that's the next step. So component tester can go away for now. No, this is a customer's board, which originally, zoom out a little bit, originally come in, it's all been in bits. He's already had a go at attempting this himself. So I can't remember what he did. He ripped some pads, he burnt part of the board, and the whole console didn't work in any way anyway. No audio, no video, literally no signs of life. I think he maybe had power. So at the minute, we've transferred all the stuff over, but it wasn't working in any way before. So we might still have issues, or all of the issues might have purely been the PCB being bad, because we've tested every resistor and cap on here, so we know they're all good because we've measured every single one. So that's a positive. We've measured every single transistor. The only one we found faulty was one down this corner, which isn't used because he's having a backlight screen. So there was one faulty component on the board, but other than that, there's no other faulty components on the board. We've actually measured them all. These chips and RAM could be bad, which we obviously don't know until we try, but my gut feeling says this is going to work, and the issues were down to his board being damaged, basically, is what I'm going to guess at. So now let's show you how to do this. So we're going to upgrade this connector to, zoom out maybe a bit. Going to upgrade this connector to like a connector like this. So instead of it being this ribbon, these ribbons don't really come off well at all. You can't really reuse them. They're very difficult to get reused. So I can get it off with solder or hot air. I did the other one hot air, so let's just show you the solder instead. And just lift off as you're going. Drag a solder ball down. And then you just have to keep feeding solder in to do this. And you can see how painful that is to do with a soldering iron. You can do it, but it takes a lot longer. And you can see you're slowly lifting it up, but the kind of, ultimately the plastic part like this is stuck down, and this one's coming off not bad, to be honest. You can see it's lifting off. So that's how you get it off with an iron. You just keep going down like this and lifting off slowly until you get all the way down. So I'll just hot air the rest off now. You've seen how you would do it with an iron. And we're not going to reuse this connector, so I'm not bothered about burning this. I'm just going to literally get this thing off. Yeah, the recapping on them is definitely a bit more tricky than normal ones. That looks like one of the pins there's. Yeah, even though that's been hot aired off and lifted clean, that little pin's missing, but this is a ground plane or a power, so 3 pins are fine. This is the tape that was holding it down as well. Got a little bit of glue, so we'll get that off. Yeah, you can see as well, even that one's come off, so these are quite weak. We'll obviously restore them when we put the connector on. And they shouldn't really rip that easy. That seems to be quite easy that it's ripped, but it's no problem to fix that. Let's first clear off the excess solder. I will probably hot air this connector on. I'll see, because we have the cartridge connector the other side. Yeah, see how these are all moving freely? There's no bonding left on this. Well, there actually isn't really bonding. You can see the open PCB underneath there. So in terms of the glue that holds these pins down, there's basically nothing holding these pins down. That's why they're moving around so easy. Just actually part of the way this part of the circuit board's been designed. So putting a connector on here is probably the best thing we can do for it, because the connector is going to anchor up and stay nice and solid, and these pins then won't be under stress either. So you can see these two pins are moving. We want to, you can reposition them while they're in, but we want to probably make a note of that we might want to, once the LCD pin's on, check these are going to the right place, or maybe even bond wire these two things over to there. We'll see what we do, but let's take note of them. They're very weak. I might just snap them off because they're moving, and then we'll solder wires. Yeah, I'm going to snap them two off because the fact they're already moving, they might be strong, but I don't want to risk that. I'm going to wiggle them off, and we're going to redo when we put the connector down. We're going to make them onto the traces. I don't want potential weak connections looking like they're good, but they're actually weak. So let's finish the job and terminate these. And it would be nice to probably just remake this PCB and have, because you can see it's a single layer PCB. That's also another reason why it's so weak. Lift this connector off and just remake this little PCB. And have the connector already on here. So that'd be a nice thing to do. So let's just clear that up. You can see it's also already, that's the popcorning I'm on about. So that's the part where we use the soldering iron, and that's where, this is what I'm on about all the time with boards where they can popcorn. And this is also a paper board, so you can't really see much and it's not going to damage much, but there's a little bit of a hump there now, very small. So you can just about see if I put my finger there, there's like a little bit of a hump there. You can normally pierce and flatten these down to get it sitting flat again. So if this happens, you can usually, looks a bit brutal, but you can stab through the board to get between the layers and then push effectively like the air out, if you will. That's what popcorning is, when it's normally from too much heat or moisture in the board. Because this is a paper PCB, so these bright orange PCBs are basically, for the most part, these are just paper, compressed paper. You might as well think of them as with a bit of bonding glue in. So fluid can get inside here and penetrate very easy. So see all these dark orange bits versus the lighter orange. That's fluid that's got in near the edge and causes that. So again, not the end of the world. It's fully functional, but we've got 3 pads to restore when we're done, and a connector to put on. So let's get the connector out. And obviously you wouldn't reuse this because this is how they come off pretty much. So where have I put the connectors? Probably in the PCN unit. Hopefully, yeah. So the goal of this one will be to position this over here, and you can see it's going to overhang slightly here, which shouldn't matter. I don't think anything's going to hit when we assemble it, but we want to get this. Yeah, we can use low melt solder as well. I've got tons. I'd normally hot air. I was just kind of showing the technique with the soldering iron, but I'd hot air them connectors off. But because I showed the hot air in the last stream, I thought I'd just show the soldering iron way at the start just to give you an idea. But yeah, I've got massive sticks of low melt solder, again from a factory where I get most of my stuff from. So huge bars, but I just never use it. It's not something I rarely need or use. Right, so let's zoom in. What am I going to do? I'll do the overhead microscope. We'll swap over to that. Zoom out a little bit. Get some light on the go. And then what we want to do now is, that's already in a quite nice position. I might try and just leave it exactly there without touching it a minute. And get some flux on there, just a little bit. I want to try and tack this into position. Not tried dental floss, no. Like I said, pretty much, I just use hot air to get most things off, and it's never a problem. And that one tacked on quite nice. So I've done a nice gentle job there. That bit's tacked on. Go all the way down. We're pretty much lined up perfectly, even right to the bottom. So that's not bad at all there. This pad we don't need to restore over here because there's 3 pads all the same. So we can flood that, get the tweezers pushed down. And that's a great anchor point. So now, if you see on the edge of the board, the black is at the very edge of the circuit board. So let's go down the other side. Oh, we don't have a circuit board. I was going to say we can line it up that way. So visually then, instead, I'd say maybe this wants to pull in slightly. We'll just have to do it by eye. Not that it matters too much. We just want it to be as straight as possible. So there we go, that'll do. I think we're straight enough there. We'll just go down with an iron and solder all these pins in. So we'll just use a little bit of flux all the way down. And what I'll do on this one is probably drag solder again. So I can show you what most people will do is they'll try and touch on one pin like this and just warm one up at the same time, like one pin at a time, like that. Oh, wasn't even that. Wow, that's not clear sometimes. Sure, the reflections off the. Maybe try turning one light off. Yeah, does that look clear enough? Let me just try. Now it's on, I don't really need to use that specifically. Let me just see if this camera's a bit clearer or not. See which one looks the best. That's a bit clearer in terms of there's not as much reflection, but I'll go to the microscope, put the lights on, and go back over. I think that's, yeah, that is more detailed. Yeah, remembering the fine, yeah, I'm definitely going to start doing that. I think this microscope camera's clear. It's just a little bit, I think the only thing I see is quite a bit of reflection, like quite a bit of shine, but that's just me trying to get it perfect. So I'm going to go down here now, and yeah, what I was saying is people trying to solder these, they'll probably just go on like one pin at a time like this, and desperately try not to touch other pins, and go down, you know, doing one pin at a time. And you can do that, but that's what leads for typically people not getting enough heat on the pins because they're scared of touching the pins either side, and they'll normally use a smaller tip because, again, they want the tip to not touch. What you can do, though, on most connectors, some connectors just have a pitch that doesn't suit this method, but what I tend to do is just drag solder. So let's give it a go. Just flood your iron with solder, get a big ball on the connector, and just drag down slowly. And if you see it's already bridging, flux on, go back up, drag down. And the back and forward just keeps dragging that ball all the way down. And then when you get to the end, you just clear your iron, warm it back up, and pull off. And now instead of going one pin at a time and needing a small tip, we've just basically done all them pins in like seconds, and you can see those pins are all nicely flown. Every one of them's got a nice solder joint on, so there's nothing there that is poorly soldered. There's no bridges, and that took what, 5-10 seconds. So that's the technique I use on most things. It's called drag soldering generally. It's just a technique you have to practice on. But the main thing is, what I try to teach you is to not panic about touching the other pins. So many people are afraid of small pins when they go, oh, how am I going to get between that? And that's where they go down this route of getting a smaller tip. And the smaller tip makes it worse because then you've got less heat transfer and then you get short. So it's counterintuitive, but this is why I use a tip that's this big. And just, as I say, go down with a big blob of solder and just bounce down. At the start, you'll probably find it dries out quick, and that's where you get your extra flux at the very start. And if you've got simply too much solder, you won't get it off the pins, so you can just ignore the start, for example, here, and then once you've done, clean your iron tip so there's no excess solder, flux back in with a dry iron, and it comes off. So just practice basically, and you can get it so that all these are fine. So now all we have to do is restore them 2 pins. I think that was the only thing. So you've got 2 options here. You can either do a nice clean connection, which is to grind away this and do a little wire join here, which is probably what I'll do. If you're not confident in that, you can tack a wire on here, follow this trace around, go all the way wherever it goes and connect to the big pin here. I'm just going to do a little connection on here because I'm perfectly capable of doing that, basically. And the only thing I'd say for soldering iron tip, I run mine at 390C. I used to run it at 420, I think, but I tend to find the tips burn out at that. But I run my iron quite hot. The only warning I'd say, if you've seen the other streams, you'll probably know, if you're going to drag solder, there are certain chips that you don't want to, well, you can drag solder on, but you need to be super delicate. So like on these, we've just, just dragging down, not really taking care of the pressure of the tip, and everything's fine. If you get, though, say, for example, the Game Gear re-PCB or the 1ASIC, these pins, the finer pitch, and if you apply much pressure, like not much pressure at all with your iron, you'll bend these pins as you drag soldering. So these you want to almost rest your tip on without any pressure and drag with no force on the tip. Even worse than that, if you go to Mega CDs, the Mega CD engine IC, which I can probably show you. These ones are, I've got the missus staring at me outside the window. She's after something. Oh, is it drink time? Oh, she's after a drink. I might have to go for a coffee. I'm getting eyeballed out the window. These pins on the Mega CD engine, these are even worse than the Game Gear. These bend so easily. So on these, I tend to lift them off, flow solder on the pins, hot air them back down, basically. So yeah, just a warning for drag soldering. You'll find out when you do it once, and then you won't make the mistake again. Mega CD. Yeah, you know when the missus has done her hair up and is standing outside that she's hinting that you need to go for a drink. So we've got to repair them 2 pins. What do you think? I can repair the 2 pins, or do you think I'm going to get told off if I don't leave immediately? Let's see if I can do it quickly. And then we can come back on. I'll come back on later then, and we'll try and bring this up. So let's see if I can do a quick trace repair on this. Get the light on. Get over there. Zoom in. Right, so this should be nice and easy. Grinding pen on the traces. We're going to just grind gently, so it looks aggressive, but going gentle on it. Done. Bit of flux. Get the fan on the go. We want to pre-tin these traces. You can see just about gets tinnable, very marginally. Tack some solder on the pins. And I'm just going to get pre-stripped, crazy strong wire. So this is that molybdenum wire, whatever it's called. Ridiculously strong wire that you can barely cut with cutters. But then I don't have to bother stripping this. Oh my god, the cutters literally won't cut through it. There we go. Get this on. Uh-oh, the door's open. Oh no, there's a fog. Let me get this wire on. Come here. We nearly did it. Yeah, molybdenum, that's the one. There you go. got rusty after me as well now. So now with this wire, all we should need to do is, there's enough solder on the board. You should just have to put flux back on here and here, and then get your super fine wire, so you can see how you can barely see it. We'll tack it onto, say, the pin first, like so. Get tweezers, come down, and with a pug bashing on the back of my Doom chair, we will get this lined up, say roughly. It's come off the other pin, but let's ignore that. Tack it down to the trace. Send that back onto the pin. Not happy with this wire. The only problem with this wire being so strong is it bends like a steel rod. It wants to bend back, like flex back into position. And you need a lot of heat to get through that wire, to be honest. So that's on. But I haven't worked with this this wire much before I brought it because it looked cool, but then it's obviously super strong. But that's actually quite difficult to work with. So I can't even cut through with scalpel. It's ridiculous how strong this is. Yeah, I'm going to take that off. We'll do it with the conventional wire. That's so strong I can't even cut it off either. So let's just take that off. Same technique though, but let's just use good old faithful, the enamelled wire. So I'm just going to strip the enamelled wire back. Got that. Right. Where's he gone? Oh, he's left now. I was just going to bring him up on stream and he's gone back to his little sitting position. He's left me alone a minute. Right, so let's get onto this. So I've got some normal enamelled wire. Do exactly the same as what we just did. Probably need a bit of fresh flux now. And then you can go onto the pin. That's better when you're used to working with it anyway. And then go down to here, bend it into position. And I haven't stripped that wire the best. It's still got a little bit of the red enamel on. But what I'll do is hold it in position and strip it while it's there. So this will try and fly off with all the heat, but there we go, much nicer. So just push down, apply the hot air, and then just leave it for a few seconds and it'll all completely bond and look nice. And then you can nice and easily cut this one. And that's what you end up with. I'd say that's a nice looking one, nice and clean. Made it look a bit more difficult there, messing with the other type of wire first, but again, something that most people would probably think is quite hard, just comes down to a technique. There's not much skill there. There's just choosing the right wire, the right technique. And that's about it, really. Technique and wire. Right. Let me just do the same on the other one. We will get that on. So we'll tack on to, tack onto this pin. Actually, that's got a bit of a bend on. Let's cut that tiny kink off the end. So tack onto there, nice and straight, like so. Bend it in to position, so it just looks like the trace, like so. I'm just going to hold down with the tweezers down here, so if it does melt, it should stay in position. Tack on. Probably best cutting this one first because I can't get the this wire's getting in the way. Get that out of my way, and then I can get the tweezers this side instead. we go. And then you can tell it's on when you push and it doesn't move. So that is how you do a bit of trace repair. We've got another one. Oh yeah, we've got the other one. Just quickly do that one, straight line. Same technique then. Straight line. Speed running soldering. Flux on there. Get the enamelled wire. The longest part of this job is just stripping the enamelled wire. That's all stripped. Fresh flux. Straight line. And straight lines are nice and easy. You can blob one on there, blob one on there. You can even melt the two together while it's connected on there. Cut the trace. Well, don't cut the trace, cut the wire. And there we go. I get coffee reward now. Let's get this on. Otherwise, she'll be going without me. And that won't be good. Up. That's off. I don't know whether to keep that molly dim and wire, whatever it is. It's I think it'd be good for other things, but yeah, I need to practice on working with that. That's quite difficult. Yeah, I can't hear her and I can't see her. She might have already disappeared. I'll be back on in 2 minutes or so. So that's probably get a bit of heat on that to clear that up, but that's basically how you repair them traces. Is that all the way zoomed in? Yes, it is. So let's use the extra zoom, but yeah, that's a nice repair. Now you could cover these in conformal coating or the resin or something, but I'm not going to. This is such a simple repair there, and nobody should be going in here with hot air or rework anyway, so I'm just going to leave them exposed basically. So we have now the connector on here, all the pins repaired. We want, I'm trying to clean my desk up a bit. Yep, everything's on there. I've got to just clean the desk, but short of, well, sorry, let's clean the desk. There we go. Right, so now we can connect these two boards together. That's rock solid as well because the pins, there's that many pins on this, they're rock solid, they don't even need fixing. Yeah, funny enough, as I was saying that, you said, can I solder the ground plane? I can, but honestly, this is rock solid, like absolutely rock. I'm trying to bend it. You literally can't even bend it off the board. So because it's such a wide pitch and large connector, you literally don't even need to in this instance, but you normally would, yeah. That was my concern with this originally, was fixing it in with no mounting points, but it actually holds itself in perfectly fine. Yeah, this is connector in there. And then connect to this side. This is quite cool, having a connector. How is putting the connector in harder than repairing the trace? There we go. So we now have a nice PC Engine GT that we can put a game in, and this might boot. So I'll bring this up later on stream, we'll have to apply power slowly and make sure the regulation circuit works and we don't overvolt, because this is obviously the first check. If we then get 5 volts, we can put a game in, probably put headphones in and listen for game audio maybe. But yeah, I'll try and bring this up later. But for now, I'm going to see if I can go for a coffee or whether the message has ran off. So sorry for the darting, guys, but I don't want to miss that. Heat gun advice worked great. Don't have a PCB, so I could trace out a spare board with Dremel. I'll order 2. Nice, yeah. I'd definitely give that a practice with the QFN. I can also show some more practicing on stream as well. I mentioned if people jump on the sub and sub to the channels, I'll be doing like subscriber only videos. Pretty much what I'm kind of doing here partially is like showing you how to do stuff. That'll become subscriber only stuff, and the main streams will focus on the doing the work, not so much showing you the techniques. That'll be part of like the subs. So yeah, I will catch you later on. I'll jump back on later and I'll literally leave this. I won't do anything to it until we come back on, and then we'll try and bring this up either later or in 2 hours. I've just got to get on with some work now as well. And so yeah, catch you shortly.